Hello everyone, today we are discussing about the self-induction as well as we can derive the expression for self-induction. So here I have an inductor and this inductor is connected across this battery through this key K. Okay, this is a battery E, and whenever you turn on the key or when you close the key, then current is started flowing through this inductor, and this produces an induced EMF in the coil. The direction of induced EMF is such that it opposes the growth of current in the circuit. So when you again open this key, then the current in the circuit is start decreasing. It will not immediately come to zero. Slowly it is what started decreasing. As a result of this, the magnetic field lines linked with the coil start decreasing, and the EMF produced in the coil so that it opposes the decrease of current in the circuit. Means in both the case, whenever you close the key, slowly current is started increasing in this circuit, and because of that EMF is also induced, and also the increase in current is also opposes by the inductor. And when we open the key, in that case also current is slowly decreases, and due to that EMF is induced, and that induced EMF is also opposes this decrease in the current. Okay, so during this both growth and decay of the current in the coil, and opposing induced EMF is produced in the coil. This is what called as a back EMF, or also we can call it as a induced EMF. So we can define here self induction as a phenomena to which an opposing induced EMF is produced in the coil as a result of change in current or magnetic flux linked with the coil is called as a self induction. Here self induction opposes both the increase and decrease of the current, and this is called as a inertia of electricity. So in short, the EMF induced in it, and because of EMF induced, or who is responsible for the induction of this EMF, the flux is responsible. So this flux is directly proportional to I, because number of fill lines due to pressing of keys and opening of the keys, number of fill lines passing through this coil are increases and decreases, and we know that how many fill lines are passing through the coil, that is nothing but what? The flux. So flux is always directly proportional to I, and if you remove the proportionality sign here, phi is equal to L into I. So L is nothing but here coefficient of self induction, coefficient of a self induction. And if suppose current I is equal to 1 ampere, then we can say that phi is equal to L. Okay, and here self induction or self inductance of a coil is numerically equal to the flux linked with the coil. Okay, when the unit current is flowing through this, then we can write phi is equal to L. So we know that the EMF induced in the coil is nothing but E is equal to minus d phi by dt. This minus sign, because it opposes the increase and decrease the current, and here we can write it as E is equal to minus d phi by dt, and this is nothing but minus d by dt. Substitute the value for phi, which we got it here, phi is equal to Li. So substitute here L into I. So here current is continuously changing, but the inductance of the coil will remain same. So in short, we can write this E is equal to minus L di by dt. So this di by dt is nothing but what? Change in current, or is a rate of change of current in the coil at that instant. And this negative sign shows that the opposing nature of the induced EMF, and if we take a mod, okay, then this induced EMF we can write it as mod of E is equal to L di by dt. And suppose this di by dt, if we are taking it as a 1, then we are getting induced EMF E is equal to L. Okay, so the self inductance of a coil is also numerically equal to the EMF produced in the coil when the rate of change of current is nothing but how much? Unit or unity, and the unit of this inductance is nothing but Henry. It is Henry and it is denoted by letter capital H, and we can write it as L. You just rearrange these terms. L is equal to E upon di by dt. So this is nothing but self inductance, and if we take EMF is equal to 1 volt and di by dt, if we are taking 1 ampere per second, then we can write inductance L is equal to 1 volt upon 1 ampere second raised to minus 1. So it is nothing but what? 1 Henry. So thus we can conclude here the self inductance of a coil is said to be 1 Henry if the rate of change of current of 1 ampere per second induces an EMF of 1 volt in it. Okay, this is nothing but self induction. So stay tuned for the next videos. In next video I will explain the self inductance for a long solenoid. Okay, I hope understood this video. Thank you.